Hello guys, in this video we are going to discuss the solution of the problem longest subsequence. So let us look at the problem statement. The problem statement says that given an integer array A of size n, find the length of the longest subsequence such that the absolute difference between adjacent elements is 1. So let us try to understand the problem statement with the help of an example. So let us take an example. Here the size of the array is 7 and the array which is given to us is this. So what we have to do is within this array we need to find a subsequence such that the absolute difference between adjacent elements is 1. So if we look at this example carefully, we will see various subsequence such that the absolute difference between adjacent element is 1. So for instance, 10 and 9 is one such subsequence. Similarly, 10, 9 and 8 is another subsequence. 4, 5 is another such subsequence. 4, 5, 4 is another such subsequence, and many more. So what we need to do is there exists various subsequence where the difference between the adjacent element is 1. So what we need to do is we need to find the maximum length subsequence and we need to return its length. So for instance, in this case what we need to return is 3. Since 3 is the maximum subsequence such that the absolute difference between adjacent element is 1. So that's about the problem statement, folks. Now let us discuss the solution of this problem. So in order to discuss the solution of this problem, let us take the same example which we have where the size of the array is 7 and the array which is given to us is this. So let us say that this is the array which we have, and let us see using this array how we will be able to come to our answer. So what we are going to do is we are going to take one element at a time, and once we are at an element we are going to compare that element with the rest of the element. So we are at this position, so we are going to compare 10 with all the elements starting from I plus 1, which simply means from 1th position. So let us compare 10 against all the elements and populate our DP table. So we will also need a DP table of size n. So here the size of the DP table is n. So now let us compare all the elements and populate that info in the DP table. So what we are going to do here is we are going to compare 10 and 9. And we are going to check what is the absolute difference between the elements. Here the absolute difference between the element is 1. Since the absolute difference between the element is 1, so that forms a valid subsequence. Since it's formed a valid subsequence, now we are going to compute the length of the subsequence. Now the length of the subsequence is 2 here, since 10 has not formed any subsequence prior to this, because of which the length of the subsequence is 2. Moving forward, 10 and 4 does not form a valid sequence, so we are going to mark it as 0. Similarly, 10, 5, 10, 4, 10, 8 and 10, 6 does not form a valid subsequence, because of which we have populated all these entries with 0. Now let's move to the next element. The next element which we have is 9. So 9 will be compared against all the elements starting from 2. So let us compare 9 with rest of the elements and update our DP table. So before updating our DP table, what we are going to do is we are going to copy all the values in the DP table till ith element, and here the ith element is 9. So the DP table till ith element is 0 and 2. Now let us compare 9 with rest of the elements and update our DP table accordingly. 9 and 4 does not form a valid subsequence, because of which the value which was there previously will be copied here. So 0. 9 and 5, same drill, which will be 0. 9, 4, same drill, which will be 0. So 9 and 8 forms a valid sequence. Once we realize that it forms a valid sequence, we need to find the length of the subsequence. Now here if you see 9, this entry I am talking about. So 9, the corresponding entry in the DP table is 2. That simply means that 9 has formed a sequence already whose length is 2. And in this case 9 has formed a valid sequence with 10. Its length is 2. After this, 9 is also forming a valid sequence with 8. So that simply means that the new sequence is 10, 9 and 8 and the length of this sequence is 3. And the way we are obtaining 3 is the length which is mentioned here plus 1, right? 8 is the new addition in that sequence, so that is why it plus 1. So now here we realize with 9 and 8 it forms a valid sequence, and the length of that valid subsequence will be 3, and between 3 and 0 the maximum element is 3, so we are going to put 3 here. Let's compare the next element. 9 and 6 does not form a valid sequence, so the previous value will be copied, which is 0. Now let's move forward. The next element which we have is 4. So before updating or before working on 4, let us copy all the values till 4. 0 to 0 has been copied. Now 4 and 5 forms a valid sequence. Here the length of the subsequence is 2, and since 4 does not form a subsequence prior to this, so because of which we can update it 2 over here. 4 and 4 does not form a valid sequence, so the value will be copied from the previous value. 4 and 8 does not form a valid sequence, so because of which the previous value will be copied. 4 and 6, again same thing, so 0. Now let's move to the next element. The next element in our queue is 5. So before operating on 5, let us copy all the values in the DP table till 5. So this value we already have. Now let's work on the rest of the elements. So let us compare 5 and 4. On comparing 5 and 4, we realize that it forms a valid sequence. Now let us compute the length of this valid sequence. So we saw that 5 already has formed a valid sequence of length 2, and a new element can also be added in that subsequence, because of which the length of the new subsequence will be 3. And between 3 and 0, the maximum is 3, because of which we are putting 3 here. 5 and 8 does not form a valid sequence, so this value will be copied here, which is 3. 5 and 6 again forms a valid sequence, because of which the length of the valid sequence will be 2 plus 1, which is equals to 3, and between 3 and 0 the max is 3. Proceeding forward to the next element. So the next element which we have is 4. So before operating on 4, let us copy all the values till 4. 0, 2, 0, 2 and 3. 4 and 8 does not form a valid sequence, so 3. 4 and 6 does not form a valid sequence, so 3. Now let's move to the next element. The next element in our queue is 8. So before operating on 8, let us copy all the elements till 8. So 0, 2, 0, 2, 3 and 3 will be copied, and then 8 and 6 will be compared, and since it does not form a valid sequence, so the value 3 will be here. Now the next element is 6, and since 6 is the last element, so this cannot be compared with any other element, so we don't have to iterate on it. Now in order to get to our answer, what we have to do is we just have to see this DP table, and we have to see what is the maximum entry or what is the largest value of the DP table. So the largest value is 3, and this is what we are going to return. So that's the explanation, folks. Now let us discuss the pseudocode for this problem. So let us say we want to find maximum LCS, and an array is given to us and the size of the array is given to us. So the first thing which we are going to do is we will have our DP table, and the size of the DP table will be n, and then we will have an answer variable, and the initial value of the answer variable will be 1. I'll explain in a bit why I am using 1 instead of 0, but for now let us proceed forward. Now let us iterate on all the elements of the array. So for I in range n, and since we have to compare every element with every other element, so let us do that. For j in range I plus 1 to n. Now what we are going to do is we are going to compare the ith and jth element. So let us compute the absolute difference between a of I minus a of j. And if this absolute difference is equals to 1, that simply means that this forms a valid subsequence. Once this forms a valid subsequence, we are going to check whether the ith element has already formed a subsequence or not, right? So essentially here we are trying to find out the length of the maximum subsequence. So for that reason, I am going to check the maximum length subsequence ith element has already formed. Let us say that this has not formed a maximum length subsequence so far, so the corresponding value will be 0. If this has not formed a subsequence so far, then in such case the dp of jth element will be equals to max of dp of j, the previous value, comma 2. because since ith has not formed a subsequence, because of which the length of the subsequence which has been formed is 2, and between 2 and the previous entry of dp of j, we are computing the maximum of these two elements, and that is what we are going to put that value in dp of j. Now since ith element has already formed a subsequence, because of which we are going to update our dp table in this fashion: dp of j, so the previous value, and the length of the new subsequence, so the length of the new subsequence will be dp of I plus 1. So once we have done this, now within the same loop we can compute our maximum. So let us say if the jth element is greater than answer, then our answer will be equals to dp of j, and towards the end we are going to return answer. So that's the pseudocode, folks. And now let us discuss the last case, which is why this value is equals to 1. The reason this value is equals to 1 is because if let us say the array is just this, which contains just one element, in that case the valid or the accepted answer is 1. Similarly, for the cases where say there isn't any valid subsequence, so for instance 2 and 5, in this case there isn't any valid subsequence. In this case also the valid answer or the accepted answer is 1, because of which I'm using 1 as an initial value of answer. So that's the whole pseudocode, folks. Now let us see how we have implemented this in C++. So we are taking a dp table of size n, and there is an answer which is equals to 1. Then we are iterating on all the elements of the array A, and we are checking if the absolute difference is equals to 1. If the absolute difference is equals to 1, that simply means it forms a valid sequence. If it forms a valid sequence, then we are checking whether ith element has already formed a valid sequence before or not. In this case, it does not have formed a valid sequence before, because of which the length of the valid sequence will be 2, and in order to update the value we are just computing the maximum between 2 and the previous value of dp of j, and that is something which we are updating in dp of j. Let us say for the case where dp of I or the ith element has already formed a subsequence, because of which the length of the valid sequence will be equals to dp of I plus 1. And again we are comparing the maximum between dp of j and dp of I plus 1, and that value will be updated in dp of j. Having updated the dp of j value, now let us see what should be our answer. If dp of j is greater than answer, then answer equals to dp of j, and then towards the end we are returning answer. So that's the code, folks. Now let us submit our solution. So our solution got accepted. That is all from this video, folks. In case if you have any question or comment regarding this video, please feel free to use the comment section and I'll try to address them. Thank you.